Hello and welcome to the Kubernetes tutorial. Kubernetes is an open-source technology developed by Google to facilitate the orchestration of containerized applications. That is why an official definition of Kubernetes is a container orchestration tool. As you can see, containers are the foundation of Kubernetes technology. So, if you want to learn Kubernetes, you must first understand what a container is and why we use them. So in this video series, we'll discuss container concepts and one of their most popular implementations, Docker. So we'll talk about what a container is and what problems it solves. We'll also take a look at a container repository, which is essentially a container resource. We'll look at how containers can make the development process much easier and more efficient, as well as how they can solve some of the issues we have with application deployment. So let's get right into it and define what a container is. A container is a method of packaging applications that contain everything they require, including dependencies and all necessary configuration. The package, like any other artifact, is portable in the sense that it can be easily shared and moved around between a development team and operations team, as well as the portability of containers. Furthermore, having everything packaged in a single isolated environment provides some advantages that make the development and deployment processes much more efficient. In later slides, we'll see some examples of how that works. As previously stated, containers are portable, so there must be some kind of storage for them so that you can share and move them around. Containers are stored in a container repository, which is a specific type of storage for containers. Many businesses have their own private repositories where they host or store all of their containers. This will look something like this, where you can push all of your containers. However, you may simply search a public repository of Docker containers and possibly find any application container you're looking for there. Therefore, let's go to the browser and check out how that seems. If I search for a Docker hub, the name of the public repository for Docker, here, I will find this official website. As a result, this Docker repository hosts or stores more than 100,000 container images of various apps, as you can see if you scroll down. The official Docker container image is available for every application, as you can see in the samples below. If you're searching for something different, though, you may search for it here. I see an official image for, say, Jenkins, but there are also a lot of non-official images or container images created by developers or even Jenkins itself. They actually store it here, so the public repository is usually where you start when you're using or starting to use containers where you can find any application image. So, let's look at some specific examples of how containers improve the development process. Before containers, how did we develop applications? When you have a team of developers working on an application, you usually have to install the majority of the services directly on your operating system. For example, suppose you're working on a JavaScript application that requires a PostgreSQL database and Redis for messaging. Every developer in the team would then have to install the binaries of those services, configure them, and run them on their local development environment, depending on the operating system they're using. The installation procedure will appear to be quite different. Another thing to consider when installing services like this is that there are multiple installation steps. So you have a couple of commands to execute, and the likelihood of something going wrong and an error occurring is quite high. Depending on how complicated your application is, the number of steps needed to install each service, this approach, or the process of setting up a new environment can actually be quite time-consuming. For instance, you would need to repeat the process 10 times for each operating system environment if your application uses 10 services. Let's look at how containers can help with some of these issues. Because a container is its own isolated operating system layer with a Linux base image, you don't actually need to install any services on your operating system. Everything is packaged in a single, isolated environment, as we saw in the preceding slides. Therefore, you have PostgreSQL packaged with a specific version and the configuration from the start script inside of a single container. Therefore, as a developer, you do not need to search for the binaries to download on your computer, rather, you can simply browse the container repository to find the required container and download it locally. The download step only requires one Docker command, which, regardless of the operating system you are using, fetches and starts the container simultaneously. With 10 applications that your JavaScript application depends on, you would only need to issue 10 Docker commands, one for each container, to start them. The Docker command used to start the container won't be any different, it would be precisely the same. That's it, which significantly simplifies and improves the setup of your local development environment compared to the prior version. Additionally, you may really execute many versions of the same application in your local environment without there being any conflicts, as we previously witnessed in a demonstration. Let's now examine how containers can make deployment more efficient. Previously, the containers would go through a conventional deployment process. The creation of artifacts by the development team will come with a set of instructions on how to install and configure those artifacts on the server. Therefore, your application would include a jar file or something similar, and you would also have a database service or another type of service. Additionally, it comes with a set of instructions for configuring and putting it up on the server, so the development team would deliver those artifacts to the operations team, and the latter would be in charge of configuring the environments to deploy such applications. The issue with this strategy is that everything must first be configured and installed directly on the operating system, as we saw in the previous example. Due to the fact that the service is operating on the same host, this can really cause conflicts with dependent version updates. Another issue that could develop from this process is when there is misunderstanding between the development team and operations. Since everything is described in a text guide, there may be instances where developers forget to mention a crucial aspect of configuration, and when that fails, the operations team must contact the developers again and request more information. This may result in some back-and-forth communication, and let's see how Docker can solve this deployment problem. With the container, the developer can run the Docker command. This may result in some back-and-forth communication, and the application is successfully deployed on the server using containers. This process is actually simplified because developers and operations are now working together in one team to package the entire configuration dependencies inside the application, just as we saw previously, and because it is already encapsulated in one environment. You do not need to configure any of this directly on the server. The only thing you need to do is run a Docker command that pulls that container that you've stored somewhere in the repository and then runs it, which simplifies the process and makes the problem that we saw on the previous slide much easier. The server does not require any environmental configuration. The only thing you need to do is prepare by installing and configuring the Docker runtime on the server before you can run containers there. But that's just a one-time effort, and later in this tutorial, we'll see how Kubernetes actually provides even more abstraction of the deployment environment to make deploying super complex applications much easier than it was possible with the traditional approach. Thanks for watching the video. It was useful, and if it was, please remember to like it because this is a video series. So I'll make one every week or so. If you want to be notified whenever a new video is released, please do not forget to subscribe to my channel. If you have any questions or if something wasn't clear in the video, please leave them in the comments section, and I will do my best to respond. Thank you very much, and I'll see you in the next video.